by taking another one beautiful example. Let capital A is equal to non-empty set A comma B. Now let us find A cross A. A cross A means this is capital A. So through tree diagrams, I wish to write A cross A, AB, AB. A is assigned with or mapped with A mapped with B, B is mapped with or assigned with A, B assigned with B, just like that. So therefore, A cross A is equal to the set of A, B, B, A, B. This is A, cross product of A, comma A. Okay. Next, here n of A cross A is equal to n of A cross A means the number of elements in A cross A. So 1, 2, each and every ordered pair is one element in A cross A. So 1, 2, 3, 4, that is equal to 4. So already we did know the number of subsets of A cross A equal to, we have one formula 2 to the power of n of this set A cross A. So that is equal to 2 to the power of 4, that is equal to 16. So we have 16 subsets for A cross A. Let us write, already we did know how to write the number of subsets of a given set and particularly all the subsets of the given set in 11th standard JEE. So I wish to recall once again the subsets of A cross A. This is the heading. Okay, we have to write 16 sets. So number one, basic points. Number one, null set is a subset of every set. So phi is subset of A cross A. Every set means here our set is A cross A. That's why null set, first set, null set. This is first one. Next, second one. Let us take singleton sets first to avoid the confusion. So the set of A, it is one set. Next, the set of the set of A comma B, the set of B comma A, the set of B comma B. In second point, 1, 2, 3, 4 subsets are there. Next, third point. So this is single element. Of course, each element is one ordered pair here. So 1, 2, 3, 4 sets are there. Now I am taking 2 elements at a time. 2 elements at a time means in permutation combinations 1, 2, 3, 4. Out of 4 by taking 2 at a time, 4C2 is equal to 6. Here we have to write 6 subsets by taking at a time 2 elements. What are they? Let us see. So for example, 1, 2, 3, 4. We have to write 6 combinations. 1, 2, 1, 2, 1, 3, 1, 3, 1, 4, 1, 4. Next 2, 3, 2, 3, 2, 4. Next 3, 4. Let us count 1, 2, 3, 4, 5, 6. Okay. 1, 2 means what? 1, 2 means first element, second element. Set of A, comma, A, B. 1, 2 elements over 1, 3. So set of A comma A, B comma A. Next 1, 4. The set of 1, 4 first element A comma A. 1, 4 fourth element B comma B. Next 2, 3 comma set of 2, 3 second element A comma B, 2, 3, third element, B comma A, B comma A. Next 2, 4, comma, set of 2, 4, 2, second element, A comma B, 2, comma, fourth element, B comma B. Already I said each ordered pair is one element. This is one element, first element. This is another element, like that. Okay, this is what? 2, 2, 4 over, 2, 4. Next 3, 4. The set of 3, 4. Third one, fourth one. The set of third element and fourth element, B comma B. Thus, we are having 1, 2, 3, 4, 5, 6. Barobar. It is verified. So, 6 elements. Right? Next, fourth point. Now, I am taking at a time 3 elements. 4C3 equal to 4. 4C3 equal to 4. So, one shortcut is there. Actually, it is 1, 2, 3, 4. By taking at a time 3, how many combinations we can make 4? How? 1, 2, 3. 1, 2, 3. Next, 2, 3, 4. 2, 3, 4. Next, 3, 4, 1. 3, 4, 1. 3, 3, 4, 1. 4, 1, 2. 4, 1, 2. So, total 4 combinations are there by taking 3 at a time from the given 4 elements. 1, 2, 3, 4 elements. We are taking at a time 3. So, 1, 2, 3. 1, 2, 3. The set of 1, 2, 3, 4, just like that. 1, 2, 3 means ordered pair of A, B, B, A. It is one subset. Next, over. Next, 2, 3, 4. The set of 2. A, B, 2, 3, 4. 2, 3, 4. B, A, comma, B, 2, 3, 4. Next, 1, 3, 4. 1. The set of 1, 3, 1, 3, 4. B, comma, B, comma, B. Next, 1 to 4. The set of 1, 2, 4. 1, 2, 1, 2, 4. B, 1, 2, 4. Okay, this is the fourth set. Next, all 3 over. Next, all means 4C4. 1, only 1. So this is fifth point. The set of all means set of A comma A, comma B, comma A. Next, B comma B, comma B. So therefore, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So total 16 subsets are there. Subsets of A cross A. So you can ask me, sir, what is the need of listing out all subsets for A cross A? Already I said one definition. Each subset of A cross B or A cross A is one relation. This is the main definition. So therefore, subset of A cross B, each and every subset of A cross B is one relation. This is the definition. So therefore, in general, let A comma B, that is belongs to capital A, and let it be R is equal to the set of A comma B, so that A comma B, that is belongs to capital A, is a subset of capital A. Then capital R is the relation is the relation on capital A, This is the main definition. So therefore, in another word, if A comma B, that is belongs to capital R, then we write it as A is R related to capital B, and we denote this we denote that we denoted by A capital R B, just like that. And if ordered pair of A comma B is not belongs to capital R, then we say that A is not capital R related to capital to small b, and we denoted by A is not R, just you strike out to R, just like that B. This is the definition. So therefore let capital A comma capital B, any two non-empty sets, and if capital R is subset of A cross B, and if the set of ordered pair of A comma B, so that A is from capital A, small b is from capital B, capital B is subset of A cross B, then R is one relation from capital A to capital B. This is the generalization or general definition for the relation defined on so and so set. Okay. Next, we discuss some different kinds of relations. Namely, number one, reflexive relation. So I wish to explain the definition of different kinds of relations through the same example for easy understanding. Look at the board. Reflexive relation means what? For example, let small a belongs to capital A. Here we see that small a belongs to capital A. First of, and capital R is subset of A cross A. First of, if R is equal to the set of, means what? We can write like that. If simply the ordered pair of A comma A, that is belongs to capital R, then capital R is called the reflexive relation on capital A. We should write the definition like that. Okay. So 1 minute. Here in the same example, I am taking only this. This, for example, let us write A, B, where is? I will take this subset here. In the above example, the set of A comma A, B comma B. Let us consider this set. Name it just like R1. R1 is equal to the set of A comma B comma B. Actually, R1 is a subset of A cross A, because actually these 16 are subsets of A cross A. I wrote simply R1 is subset of A cross A, and here A comma B are belongs to capital A. Once again, look at the board. Small a comma small b belongs to capital A, and R1 is a subset of A cross A. So for for all A comma B that belongs to capital A, R1 is equal to the set of A. A means A comma A, B comma B, B comma B. So R1 contains these elements. That's why R1 is called reflexive. R1 is called reflexive relation on capital A. This is the best example. Another example, we can take another example. R2 is equal to while first point is A comma B, that is belongs to capital A, full stop. Now I am taking another subset R2. For example, AA, BB, where is that? AA comma BB. I will take this set R2. I am saying R2. The set of A comma A, next B comma B, next B comma B, next B comma A. Let us consider 1 minute. A comma B, that belongs to capital A. Okay, next R2. Out of 16 subsets, I am taking only this subset. We are considering this subset. Name it as R2. So R2 is equal to A comma A, B comma B, B comma A. So how many elements are there in R2? It is out of question. We have nothing to do with the number of elements of R2. Just I am asking only two questions. Is A belongs to capital A? Yes. Thus A comma A belongs to R2? Yes. Next, another element is there, B. B belongs to capital A? Yes, sir. B belongs to capital A? Yes, sir. B comma B belongs to capital R2? Yes, sir. So therefore, R2 is reflexive relation on capital A. Therefore, for all A comma B, that is belongs to capital A comma A, and B comma B, that is belongs to capital R2. Therefore R2 is also reflexive relation on simply A or A cross A. This is the complete definition of reflection relation on certain given set capital A. Once again, if A belongs to capital A, so simply we can define like that. Therefore, for all A belongs to capital A, if small a comma A, it is also belongs to capital R, then capital R is called as reflexive relation on capital A or A cross A. This is one definition, reflexive relation. Next, number two, reflexive symmetric relation. Symmetric means, for example, so definition, first definition. Let A comma B, that is belongs to capital A. If A comma B belongs to capital R, then B comma A is also belong to capital R, then R is said to be symmetric relation on capital A. 1 minute. I will show the reflective symmetric relation in our 16 examples. You come here. So already I wrote 16 subsets of A cross A. So A comma B. Definitely B comma A should be in capital R. Then only it is said to be symmetric relation on capital A. This is the definition. Okay. Let us see, out of 16, I will take this relation. For example, its name is R3 in our example. In the above example, Example, R3 is equal to, I am taking this, the set of ordered pair of AB comma BA belong BA set clause. Okay, it is R3. So I am telling that R3 is reflective symmetric relation. R3 is symmetric relation on capital R. So verify it. 1 minute. Here A comma B, it is belongs to R3. Okay. A comma B, this ordered pair, this element is in R3. Okay. Now take reverse order. Take reverse order. Is B comma A that belongs to R3? It is my question. It is my question. Your answer is yes. Yes. Is it correct? Yes. Therefore, yes. Therefore, R3, therefore 1 minute. Okay, first. Next, so this is the first element. This is the examination for first element. Next, take another element. Take another element. B comma A, that is already belongs to R3. Belongs to R3. Belongs to R3. Next question is reverse order. A comma B. A comma B, that is belongs to R3. Kuchinna. Your answer is what? Yes. Yes. Therefore, for first element, mind it, first element for A comma B, that is belongs to capital R3, implies B comma A is also belongs to R3. Second element B comma A, that is belongs to R3, reverse order. A comma B is also belongs to R3. So total how many elements are there in our example? Only 2 elements. So 2 elements are finished. So how many elements are there? Verify for all elements like that. If another element is there, verify like that. Okay. So this is the verification of symmetric relation. So therefore R3 is called symmetric relation. Symmetric relation. R3 is called symmetric relation. Once again, if A comma B belongs to capital R, then B comma A is also must be belongs to capital R. Then only this R is said to be symmetric relation on the given set capital A. This is the simple definition of symmetric relation. Okay, we can show the number of examples for every definition. So for easy understanding, I took the examples, suitable examples for the definition from the basic only. Remember it, recognize it. Okay, next third one, transitive relation. Transitive relation means what? First, I will write the definition. If A comma B and B comma C, that is belongs to any set capital R, then okay, it is B common, second element B in the first ordered pair or in the first element, that the same element is repeated in the first coordinate. Once again, this is the first element. Second coordinate is same as first coordinate in the second element. Understand? This is the first element. It is the second element. Observe. In the first element, second coordinate is same as first coordinate in the second element. Then A, C, remaining letters A, C must be belongs to capital R. Capital R. Then R is called transitive. R is called transitive relation on capital A. Whereas A comma B comma C are in The main set capital A. Of course, capital R is a subset of capital A. It is to be understood that capital R is subset of A. Okay. Example. It's called a transitive relation on capital A. Let us take one example. Capital R is equal to, say, capital R3, R4, R4. You can name it as any letter or with any letter R4, just like R4. R4 is equal to, I'm taking this example, or this is subset. So A comma B, next B comma A, next B comma B. So capital R4 is the transitive relation on capital A. So already I did know R4, this subset is a transitive relation on capital A. You can ask me how it is true, how far it is true, sir, prove it. Okay, first A, first letter, A comma A. So this is ending with A. So take another ordered pair starting with A. How many starting? So this is the first element. I took the first element. In first element, this is the second coordinate. So take another element starting with A. So this element is there. Okay. Any more elements are there starting with A? No. After taking this. Okay. Now it is in the form of A, B, B, C, just like that. Okay. Just you strike out A to represent the same. Next, remaining. So what I am telling that these two elements are in R4. So implies after striking out same elements, second coordinate, here first coordinate. Now what are the remaining elements? A comma B. A comma B. I am asking one question. Is belongs to again R4 question mark. Is A comma B belongs to again R4? You come here. A comma B is there. A comma B is there. So for first it is yes, correct. So yes, your answer is yes. Next, I am taking second element. Which one is the second element? This is the second element. You write second element. A comma B. So ending, it is end with B. So starting with B, how many elements are there? This one. Okay. Take first this case. Next this case. B comma B. Two subcases are there. Okay, BB same. Next remaining. So it is belongs to R4. Then is A. Remaining element. A. You look at the board. A. This A. A comma A. Is A comma A belongs to again R4? It is my question. You verify. A comma A. A comma A is there. Yes, your answer is yes. Okay, next. Take third element. Which one is third element? This one is third element. Third element. B comma A. End with A. Take starting with A. Starting with A, how many elements are there? Two elements are there. So 2 means what? A comma A. And B A comma B. Just like that. Okay, it is, of course, it is belongs to R4 and we can put the same BB same A comma B. It is A comma B is again belongs to R4. Same question. Is it correct? Your answer must be yes by observing this R4 set. Next, third B comma A. It is end with A. So starting with A, actually in our given set, two elements are there. We wrote two elements. Now we are verifying. So these both are same. Then it is belongs to capital R4. So is remaining B comma A. B comma A is belongs to R4. It is my question. You verify the set B comma A. B comma A is there. B comma E is there. So your answer must be yes by observing the given set R4. Yes. Next, verify the same conditions for this set. So AA same. Of course, this element belongs to R4. Now my routine question, after striking out, after saying both are same, the remaining first, this is last, B comma B. Is B comma B that belongs to R4, again B comma B, verify. B comma B is there. So yes. So yes. So your answer is yes. So this procedure is satisfied for every element in the given set R4. Therefore, thus R4 is transitive relation on capital A or A cross A. This is the verification of transitive relation. Let us verify. Next, I wish to take another example for failure case. You see, A comma B. Where is that? A comma B. A comma B. Let us consider this one. The set of, let us consider the set, say R5, that is equal to A comma A A comma A or A comma B. कट कर